Hello, you're welcome to the chemistry series with Excellence Simplified, and today we are going to be looking at atomic structure. Now, an atom is the smallest particle of an element which takes part in a chemical reaction. So the smallest particle of an element that can take part in a chemical reaction, that smallest particle of an element that can take part in a chemical reaction is called an atom. Now we are going to look at the structure of this atom. So let's start with the subparticles, the subatomic particles. Now this is an atom. This is how the atom looks like. Now the atom has two parts. The two parts of an atom is a nucleus and the shell. Now if you don't call it the shell, you can call it the orbitals. Now this nucleus here contains two subparticles, the proton and the neutron. So please take note that proton is found in the nucleus and neutron is also found in the nucleus. While the shell or the orbital, you can see this is one shell. This first cycle here, this is one shell, this is another shell, this is another shell, and it continues like that. It continues like that. Now, the electrons revolve around the shell, revolves around the shell. So electrons are found in the shell. Please take note because it's exam concentrated area. Nucleus, proton and neutron is found in the nucleus, while in the shell we have electrons. So electrons are found in the shell. Now, this first shell here, you're seeing is called the K shell. The second one is called the L shell. Guess the third one? M. So it's just like you're counting A, B, C, D, but you're starting from K. K, L, M. The next one would have been what? N. Like that. So it continues like that. Take note. First shell is K shell. Next shell is L shell. And next one is M shell. And remember I said that electrons revolve around the shell, right? Electrons revolve around the shell. Now take note of this point. This K shell is peculiar because only two electrons can occupy this K shell. Only two electrons can fit into this K shell. Are you following? Only two. So once you have two electrons fixed into the K shell, no more electron can be fixed into the K shell. Any other electron coming in will move to the next shell. Now, the K shell can hold on maximum of 2 electrons. The L shell can hold a maximum of 8 electrons. So we have 8 electrons. The M shell can hold a maximum of 8 electrons as well. And so as the other ones, 8, 8, 8, 8, 8, 8. But this first shell is how many? Can hold maximum of how many electrons? 2. The next one can hold 8. The next one can hold 8. 8, 8, just like that. But the first one, K shell, holds a maximum of how many? Of 2. Please take note of that very well. I've said that proton and neutron is found in the nucleus, while the shell, we have electrons. And 2 electrons are found in, a maximum of 2 electrons are found in the K shell, while 8 are found in other ones. Now let's look at some of the subatomic particles, their charge, relative atomic mass. This AM here is atomic mass, relative atomic mass, and their location. First, the proton. Now, proton has a positive charge. Proton is what? Is positively charged. And so the charge is +1. Now, the relative atomic mass is 1 AMU. This AMU means atomic mass unit. So the relative atomic mass of proton is 1 atomic mass unit. And where is the location? Remember I told you that proton is found in the nucleus. So the location is where? Nucleus. The next one is neutron. And neutron has a charge of 0. Now, 0 charge means it is not positive, it's not negative. So neutron is neutral, does not have charge. Are we following? The neutron does not have charge. That is why we put the charge here as 0. Now, the relative atomic mass is 1 atomic mass unit. And it is also found in the nucleus. Now, look at it. We said neutron is found in the nucleus. If you notice here, you discover that the proton and neutron have the same relative atomic mass. So they have the proton and neutron are approximately equal in size, so 1 atomic mass units. Now the electron here, electron is negatively charged with the charge -1. And please take note here, the relative atomic mass unit, so the relative atomic mass of electron is 1 over 1836 atomic mass units. Now you can see if you press this on your calculator, that will give you 0.000 something. That is very, very tiny compared to 1 of proton and 1 of neutron. So, and where is it found? In the orbitals, or you call it the shell. So it's found in the orbitals. You don't call it orbitals, you call it shell. Now, please note that I've said that electrons are found in the shell, while protons are found in the nucleus. Protons and neutrons are found in the nucleus. Now, please check this. Proton is positively charged. Electron is negatively charged. Neutron is neutral. It means that in a nucleus, since the nucleus is proton plus neutron, proton positively charged, neutron is negatively charged. Now, proton here determines determines the charge of the nucleus. So what will be the charge of the nucleus overall? Will be positive, because proton is positively charged and neutron does not have charge. Are you following? All right. Now, we've said that electrons revolve around the shell. Now, the first shell here is called the K shell, L shell. The second one is L shell. The next one is M shell. Now, this first shell here, this K shell, can hold a maximum of 2 electrons. So only 2 electrons can fit into this K shell. Now, the next one can hold a maximum of 8 electrons. The next one, 8 electrons, just like that. All right, so basically, there is this. Now, nucleons are nuclear particles. Anytime you hear nucleons are nuclear particles. And what are the nuclear particles? Nuclear particles are those subatomic particles found in the nucleus. And what are the atomic particles found in the nucleus? Proton plus what? Neutron. So anytime you hear nucleon, just know they are talking about proton and what? Neutron. Do you understand? Because those are the nuclear particles. Now, they determine the atomic number and mass number. So it is the proton and the neutron that determines the atomic number and the mass number. Now, atomic number is represented as Z. And the atomic number of an element is equal to the number of protons in that element, in the atoms of that element. Now, the number of protons equal to the atomic number, and it is designated as what? As Z. Please take note of that. And for a neutral atom, proton equals electron. For every neutral atom, proton equals electron. Why is it so? Now, if you have something like this, proton, remember, proton is positively charged, while electron is negatively charged. Now, if the proton, say, is +3 and the electron is -2, what will be the overall charge of the atom? +2 minus 2, +3 minus 2 will be what? +1. So you see that the atom will be charged +1. If the electron is, say, -4 and the proton is +3, what will be the overall charge of the atom? +3 minus 4 will give us what? -1, right? Meaning the atom will have an overall charge of -1, negatively charged. So for the atom to be neutral, the proton must be equal to the electron. For example, if the proton is +3 and the electron is +3, sorry, the electron is -3, +3 minus 3 is equal to what? 0. Net charge of 0. So now, for the atom to be electrically neutral, number of protons must equal to the number of electrons. If the atom is having a charge, just know that the proton is not equal to the what? The electrons. Are we following? Just know that the electron is not equal to the protons. It has acquired an electric charge, either positive or negative. So it is now an ion. It is now an ion. Do we understand that? So for a neutral atom, proton equals electron. Now, the number of protons in an atom, we already know it is the number of protons in an atom determines the mass, the atomic number, is the atomic number. But now, also take note that the number of protons in an atom is called the nuclear charge. Nuclear charge. Why is it called the nuclear charge? In the nucleus, we have proton and neutron. Proton is positively charged. Neutron does not have charge. Neutron does not have charge. So since it does not have charge, what determines the charge of the nucleus is the proton. So you agree with me now that the nucleus is positively charged overall because of the proton present that is positively charged. Now, the number of protons in an atom is called the nuclear charge because that's what gives the nucleus its charge, positive. Are you following? All right, moving on, the mass number is designated as A. Don't forget that the atomic number is designated as Z. Now, the mass number of an element is designated as A, and mass number equals protons plus neutron. Now, let's come back to the atom here. Remember that proton has a relative atomic mass unit of 1, relative atomic mass of 1, neutron 1, electron 1 over 1836, which is very, very small. It's negligible. In fact, we don't even consider it because it's too small. So most times we just say electron does not have mass because it's very, very tiny. Now, what determines the mass of the atom then will be this one and this one, proton and neutron, found in the nucleus, because the electron does not, the mass is very, very small. So the proton plus the neutron will determine the mass of the atom. That is why we said the mass number is protons plus neutron. Are you following? So mass number is just protons plus neutron. And remember, we've said that A represents the mass number and Z represents the atomic number. This X is used to represent a theoretical element. So let's just, a hypothetical element. So let's just assume this X stands for anything. A here represents the mass number and Z here represents the atomic number. Please don't be confused. Don't say A, atomic number, Z, mass number. Now, if you look at this stuff here, this 35, right? This 17. This 35 here represents the what? Mass number, right? While 17 here represents the atomic number of that element. Now, let's do some exercise. Here we have mass number A. Here we have atomic number Z. Here we have proton, electron, and neutron. We have to complete this table. Please pay great attention because in most exams you see this. Now, the mass number here is given as 1. We're not giving atomic number. We're giving proton as 1, electron as 1, neutron we're not giving. Now, let's fill up this. What do you think will be the atomic number? The atomic number will be what? Remember, atomic number is equal to the number of what? The number of protons. And number of protons there was given as what? 1. So atomic number will be equal to what? 1. Because atomic number equals the number of what? Protons. Now, we have neutrons here. We're not giving. How do we get neutron? Is that a problem? Never. Now, remember that mass number is equal to proton plus what? Neutron. In this case, we're giving mass number as 1. We're giving proton as 1. How do we get neutron? Let's make neutron the subject of the formula. Neutron will be equal to what? Mass number minus what? Proton. Just carry this one here. So the neutron will be equal to, what's the mass number here? 1. Minus, what's the proton? 1. So 1 minus 1 is what? 0. So the number of neutron is what? 0. Is it not simple? It's as simple as that. Let's look at the second one. The mass number was given as 12. Atomic number was given as 6. Proton was not given. How do we get proton? Remember that proton is the number of, is the same thing as what? Atomic number. And atomic number was given as 6. So you just close your eyes and write 6 here. I'll do this one, then I'll leave this last one for you. Now, here we're giving mass number as 23, atomic number as 11, proton as 11, electron as 11. Now, the neutron, how do we get neutron? Remember, neutron is mass number minus proton. Mass number was given as 23, minus proton was given as 11. So, 23 minus 11 will give us what? Give us 12. So, the neutron is equal to 12. The last one, we're given mass number as 39, atomic number we're not given, proton 19, electron 19, neutron we're not given. Now you're going to do that and drop it in the comments section. So I will know if you are actually following. Remember, this is a chemistry series that covers from the first topic to the last topic in chemistry. So if you've missed any topic in the series, go back and watch those the topics you've missed out already. Now in the next topic we are going to be treating, in the next video, still continuation of this topic, we're going to be looking at the different models of the atom. Different persons came up with their own model. This is how the atom looks like. This is how the atom looks like. We are going to look at the different models. We are going to look at the Dalton's model. We are going to look at the Rutherford model. We are going to look at Bohr's model. We are going to look at quantum mechanics model and the different models. We compare them simply. Even if somebody that was born yesterday, you still understand. So anticipate that video is dropping soon. All right, now if you're not subscribed to my channel, please click on the subscribe button, like this video, share it to your different platforms. That's the only favor you owe me. Share it to your different platforms. Share it to anybody you feel needs this video. See you in the next video. My name is Excellence Simplified.